Hi folks, I think you people are doing great and having your safest life over there. In this video, let us derive the expression for de-broglie wavelength. And let's start the video. Consider a photon of frequency nu and a wavelength lambda travels with a velocity which is equal to the light c. See, to study physics, you have to be strong with your imagination because you have to assume a lot of things, okay? Okay, after that, we have, let m is the relative mass of the photon. So we have mass of the photon, that is m, and the energy of the photon is E is equal to h nu, and we have the energy of the photon, that is E is equal to h into nu, and we know the energy of the photon just by the Einstein equation, that is E is equal to mc square. E is equal to mc square. So here left hand side is same. We have to compare the right hand side. We can compare the right hand side. That is what we are doing to derive the expression for de Broglie wavelength. And here we have compared that particular thing, that is mc square is equal to h nu, and we are replacing this nu with c by lambda because it's well known equation. Okay, after this we're gonna just canceling out the c's. Here we have two c's, so we have left out with one c over here, that is mc is equal to h divided by lambda. We want the expression for lambda, just we were replacing that lambda part over there, and h divided by mc, lambda is equal to, and here mc is equal to p, which is equal to momentum of the photon, because therefore the lambda is equal to h divided by p. H divided by p. This is the expression for wavelength of the photon. De Broglie assumed that the above equation is general formula which holds good for material particles. Also consider a particle of mass m moving with a velocity v, then de Broglie wavelength of the particle is given by lambda is equal to h divided by p, where p is equal to mv, is the momentum of the particle. As you all know, p is equal to mv, this is the momentum of the particle, so we replace this p with mv. Okay, we replaced the p with mv, and after that, assume the not assume, we know the formula for kinetic energy, that is k is equal to half mv square, half mv square. Okay, and we are multiplying and dividing the equation to this equation with m. Okay, we are multiplying m and dividing m. So if you multiply m to the numerator, it will become m square into v square into 1 divided by, if you multiply the m to the denominator, we get 2 into m. Okay, p, we know that p is equal to mv. If we square both sides, what do we get? P square is equal to m square v square, right? So we can replace this m square v square with p square. So we, let's replace that particular thing. So we replace this m square v square with p square. Okay, after that we want the expression for in terms of p square, so we are keeping the p square over here, and we're sending all the terms whatever there to the left hand side. So we're gonna get 2mk is equal to p square. So we want the expression for p, keeping the p send the square to other side. So we're gonna get p is equal to root of 2mk. So replace this p value over here with 2mk, this p value with 2mk, root 2mk. So we're gonna get the de Broglie wavelength lambda, which is given by lambda is equal to h divided by square root of 2mk. I think you people have got it. And then consider an electron of mass m and charge E accelerated through a potential difference V. The kinetic energy of the electrons is equal to work done on it by the electric field. So we have K is in electric volts. Okay. After that, we have the lambda equation, that is h divided by root 2 mk, and we're replacing this k with ev. Okay, just we're replacing this k with ev over here, substituting h, m and e value over there. So we're gonna get this constant value, that is 12.27 divided by square root of v, and we have Avogadro number multiplied with Avogadro number. So this is how to derive, this is the way to derive the expression for de Broglie wavelength, and this is the extra statement which you have to concentrate. It's not carry any marks, but just for your reference I have written over here. De Broglie wavelength is more for the heavier particles and more for the lighter particles like electrons. The de Broglie wavelength of the macroscopic particles cannot be measured for subatomic particles. The de Broglie wavelength is of the order of 10 to the power of 10, 10 to the power of minus 10 meter, and it can be measured. Darvish and German experiment and G.B. Thomas experiment on electron diffraction confirms the wave nature of matter. That's all from my side, and I hope I have conveyed whatever the thing is there in my mind to you people. And thanks for watching. Happy learning.